So here we will be talking about SDS Page. SDS Page is a gel method used to separate proteins based on their molecular weight. Now, in our previous video, we did talk about gel electrophoresis. So SDS does have a couple differences from our agarose gel, more specifically known as the gel that we have used to separate our DNA. Now, for one of these differences is that SDS is ran on a polyacrylamide gel, and this is typically because proteins run a lot more smaller than DNA, and the polyacrylamide is known to have a very small pore size rather than the agarose gel. Another difference is that proteins are also ran at a constant current. Now, before we look at our gel, we're going to be looking at our proteins, or our positive and negative clones in which we have selected. We see that in our first 1.5 ml tube, we have our GST with our EGFP, known as our fusion protein, also known as our positive control. In our following 1.5 tube, we have only our EGFP, and that is only known as our negative control. Now, the EGFP and the GST fusion proteins, these are known as our PET plasmid. And this is our PET plasmid with the fusion, with the empty vector by itself, known as the negative, or the PET with the EGFP, known as our positive. Now, what we will do is we will go ahead and add loading buffer into our proteins, or into our supernatant. And within the loading buffer, we do have BPER, which helps break down the DNA. We also see that we have SDS. So what this SDS does is it practically coats the protein as well as denatures it, making it linear and causing the entire protein to become negative. So after doing so, we will go ahead and then heat shock our proteins. We will heat shock our supernatant at 100 degrees Celsius for 10 minutes. And then is when we will move on to our loading gel. So fortunately enough, we were lucky to have this gel made for us. So we are responsible for our assembling and inserting. So here we can see that we have part of the assemble. There's more of a clear visualization on this part, here on this side, where we have our example. I will also represent, a machine as well as how everything is connected. So we see here that we have a lid, we have a gel cassette holder, and the gel cassette holder has a remaining, which is a filter pad, a filter paper, as well as a membrane, our gel, which we will go ahead and go into right now, our filter pad, and the gel cassette holder as well. And then we have our electro module. So after putting everything together, we will go ahead and just clip everything together. We will see here that this is how our sandwich shall look like. We're going to go ahead and clip it, insert it into our electric module, and go ahead and put it into our buffer tank. Now, our buffer tank will be filled with 10% precast, or SDS Page, once again known as acrylamide, which is going to go ahead and allow these small proteins to travel through the matrix. So we will see here. So this is how the electrode machine shall look like. The SDS Page machine. We see here that this is where we connect. Also, where we will be selecting our volt size and how much we will want. And then this is our entire machine. This is our buffer tank, and this is our lid, and this is everything that just has the cassette holder as well as everything that was listed. So we will see here that we will be loading our lanes as desired. First lane will be our ladder. Our second lane will be our negative, which is again only our EGFP empty. And then 3 and 4 will be our positives. We see here that once we have properly pipetted everything, all of our natants into the corresponding lanes, our proteins will then travel down. So we'll go ahead and run this at 200 for 1 hour, Once again, looking at our proteins travel down from our negative down to our positive, because as stated before, our proteins have become negative, so they will travel to the opposite charge. We will also see that here, that our proteins have been traveling down as they're being ran through. And then finally, once all this is over, after running it for 1 hour, we will go ahead and only take out the electric nodule, which contains the cassette holder. And this is how it shall be looking like. With the glass, we have the resolving gel, and then our glass as well, after removing it from the cassette entirely. In our next video, we will go ahead and talk about our Western blot as to how we will be able to identify and distinguish our proteins that have flowed down our gel from our SDS page.